No compass. No satellite blinking somewhere in orbit to tell you exactly where you are. No paper map. No engine. No radio. Just you, a wooden canoe lashed together with coconut fiber, a crew of a few dozen people, some pigs, chickens, seeds, and plants wrapped in wet leaves. And between you and your destination, 2,500 miles of open ocean. An island you have never seen. An island you only know exists because someone told you about it generations ago. Now go find it. That is not a thought experiment. That is what the ancestors of the people who settled Hawaii, Tahiti, Aotearoa, and countless other Pacific islands actually did. And they were not the only ones. Across the Atlantic, Norse sailors crossed gray, fog-filled seas to reach Iceland, Greenland, and eventually North America, nearly 500 years before Columbus. Across the Indian Ocean, Arab, Persian, Indian, and East African sailors used the seasonal monsoon winds to travel between continents on routes that could be repeated year after year. And they did all of this without GPS. In many cases, without a magnetic compass. Sometimes, without a written map. So how? How can a human being stand on a moving deck, surrounded by nothing but sky and water, and know which direction home is? For a long time, many Western scholars had an answer. They said ancient people probably did not navigate across these oceans deliberately. They drifted. A storm blew a canoe off course. The currents carried it somewhere. And, occasionally, the survivors happened to reach an island. It was a convenient explanation, but it was also almost completely wrong. The first major challenge to the idea came in 1947, when Norwegian adventurer Thor Heyerdahl built a balsa raft called the Kon-Tiki and sailed from South America toward Polynesia. The voyage proved that a raft could survive such a journey, but it also created confusion. Heyerdahl's raft had drifted with the wind and currents. It did not prove that Polynesians had reached the Pacific by accident. Modern archaeology, genetics, and linguistics tell a very different story. The ancestors of Polynesian peoples came from the west, through the Austronesian world of Southeast Asia and the Western Pacific. And they did not simply drift. They deliberately sailed. The strongest evidence came from people who still remembered how. In the 20th century, sailor and physician David Lewis traveled through the Pacific searching for traditional navigators. He found men who had learned from their fathers and grandfathers, men who could cross enormous distances without instruments. Lewis sailed with them. He watched what they watched. He learned how they read the sea, and he documented their knowledge in his book, We, the Navigators. What he discovered was not guessing. It was a complete navigation system, a system based on the sky, the ocean, the wind, the birds, the clouds, and memory. And the first part of that system was the stars. A trained Polynesian navigator did not look at the night sky and see random points of light. They saw a map, a compass, and a clock. They knew where particular stars would rise and set along the horizon. The Hawaiian star compass, later reconstructed and taught by navigator Nainoa Thompson, divides the horizon into 32 sections. Each section represents a direction, but a navigator could not simply choose one star and follow it all night. As the star rose higher, it moved away from the horizon and became less useful as a fixed direction. So navigators memorized chains of stars. One star would rise. Then another would appear in almost the same part of the horizon. Then another. The navigator could follow this sequence through the night. Star after star. Path after path. Direction after direction. According to accounts of the Micronesian master navigator Mau Piailug, navigators could memorize the rising and setting points of more than 100 stars. This knowledge was not intuition. It was training. Children could spend years learning star paths before they were trusted to guide a real voyage. But what happened when clouds covered the sky? The ocean itself became the next instrument. The sea is not random. Large swells generated by distant winds can travel across thousands of miles of ocean. They are different from small waves created by local weather. A trained navigator could feel the difference. They could recognize several swell systems moving through the same area. One might be coming from the northeast. Another might be bending around a distant island. Another could be arriving from a storm hundreds of miles away. Sometimes, navigators would lie inside the canoe at night and feel the movement of the hull through their bodies. The canoe was moving. but the swells beneath it were carrying information. In the Marshall Islands, this knowledge became so sophisticated that navigators created stick charts. These were made from palm ribs and shells, but they were not maps in the modern sense. They did not simply show where islands were. They represented how waves bent, reflected, and changed around islands. The charts were mainly teaching tools. The real map was stored inside the navigator's mind. And then there were birds. Not every bird was useful. An albatross could fly for days across open ocean. Seeing one told you almost nothing. But certain terns and boobies regularly travel from land to the sea to feed, and then return to their roosts. A bird seen in the morning, flying away from the canoe, might suggest land behind it. A bird seen in the evening, flying toward the horizon, could reveal the direction of land. The species mattered. The time of day mattered. The direction of flight mattered. One bird meant almost nothing. The right bird, at the right time, could be a clue. Clouds provided another. An island hidden below the horizon could still affect the atmosphere above it. Clouds might remain stationary over land. Their shape could reveal something beneath them. And sometimes, the light reflected from a lagoon could subtly change the color of the clouds above it. The navigator was not looking for one magical sign. They were combining dozens of small signals. Stars, swells, wind, clouds, birds, water temperature, ocean color, fish, even the behavior of the canoe itself. Every observation helped confirm or challenge the others. This was an ancient version of a redundant sensor system. If the stars were hidden, the ocean remained. If the wind changed, the deep swell could still provide a reference. If a bird appeared, it could confirm the direction suggested by the clouds. The system worked because no single observation had to be perfect. The information was constantly cross-checked. And then there was a remarkable mental system known as attack. In Western navigation, you imagine yourself moving across a map. But in the attack system, the canoe could be imagined as remaining still while an invisible reference island moved beneath the stars. As the voyage continued, that imaginary island passed through different star positions. The navigator could track progress without calculating distance in miles. Instead, they mentally tracked relationships between the canoe, the stars, the wind, the swells, and the invisible island. It was dead reckoning without numbers. A completely different way of thinking about movement. But knowing that these techniques existed was not enough. The big question remained. Could they actually work across thousands of miles of ocean? In the 1960s and 1970s, scholars were still arguing about this. Some believed deliberate, two-way voyages across the Pacific were too difficult. Others believed traditional navigators had been doing exactly that for centuries. So the argument needed more than theories. It needed a real voyage. In 1975, the Polynesian Voyaging Society launched a traditional-style double-hulled canoe called Hōkūleʻa. The canoe was designed using evidence from ancient descriptions and historical drawings. No modern navigation system would guide it. For the voyage, the society turned to Mau Piailug. He was one of the last master navigators who still possessed the complete traditional knowledge. In 1976, Mau guided Hōkūleʻa from Hawaii to Tahiti. Approximately 2,500 miles. 34 days. No GPS, no modern instruments. Only the stars, swells, wind, clouds, and the knowledge inside one human mind. And Hōkūleʻa arrived. At Tahiti, thousands of people gathered to welcome the canoe. For many, this was more than a scientific experiment. It was proof. Proof that their ancestors had not simply been lucky castaways. They had been explorers. They had crossed one of the largest and most dangerous environments on Earth deliberately. Mau later trained a young Hawaiian navigator named Nainoa Thompson. In 1980, Thompson became the first Hawaiian in centuries to navigate a traditional canoe across open ocean without modern instruments. Since then, traditional voyaging canoes have traveled tens of thousands of miles. The experiment had been repeated again and again. But there was another form of evidence. Computer simulations. Researchers modeled ancient Pacific voyages using real wind and current patterns. They discovered that a strategy described by traditional navigators made enormous sense. Sail upwind while searching for new land. If you find an island, you can settle there. If you do not, You can turn around and sail back with the wind. This strategy was far more practical than simply drifting randomly, and it matched the archaeological record. The Western Pacific was settled first. The more distant islands came later. Hawaii, Rapa Nui, Aotearoa, the final edges of the Polynesian world. The evidence from archaeology, genetics, living navigators, real voyages, and computer models all began pointing toward the same conclusion. The Pacific was not settled mainly by accident. It was explored deliberately, and the same idea appears in other parts of the world. Norse sailors crossed the North Atlantic using latitude, the sun, stars, currents, birds, and landmarks. They may also have used crystals known as sunstones. Certain crystals, including Iceland's spar, can reveal the direction of the sun even when the sun itself is hidden behind clouds. Experiments have shown that the polarization of scattered sunlight can help locate the sun's position. Whether Viking navigators used these crystals as commonly as later stories suggest remains debated. But the underlying physics is real, and the Norse had many other tools. They watched birds. They studied driftwood. They recognized different seaweeds. They observed changes in water color and temperature. They understood that the ocean itself was full of clues. Meanwhile, in the Indian Ocean, sailors had a completely different advantage. The monsoon. The winds of the Indian Ocean reversed direction seasonally. For centuries, Arab, Persian, Indian, and East African sailors used this predictable rhythm to travel between Arabia, Africa, India, and beyond. The wind could carry a ship across the ocean. Then, months later, reverse direction and carry it home. Navigation was supported by stars, coastal landmarks, seasonal winds, currents, and instruments such as the kamal. A simple piece of wood held at arm's length could help estimate latitude by measuring the height of a star above the horizon. The methods were different. The oceans were different. The cultures were different. But the underlying principle was the same. Observe everything. Cross-check everything. Remember everything. And pass the knowledge to the next generation. The most remarkable part is that none of these systems required a battery, a satellite, a computer, or even a magnetic needle. The instrument was the human body, the eyes, the ears, the skin, the inner ear, and the memory. A navigator had to learn to recognize a particular star, a particular swell, a particular bird, a particular cloud, and combine them into one constantly changing picture of the world. Today, we think of navigation as a problem solved by hardware. A compass, a phone, a satellite. But for most of human history, navigation was a problem of wetware. The technology was inside the human mind, and that created one enormous weakness. If the knowledge was not passed on, it could disappear. That almost happened across the Pacific. Colonization, missionary pressure, population loss, and the convenience of modern instruments pushed traditional wayfinding toward extinction. Mau Piailug understood that he might be one of the last people alive who possessed the complete system. He faced a difficult decision. Should he keep the knowledge within his own tradition? Or should he teach it to outsiders before it disappeared completely? He chose to teach. And because of that decision, the knowledge survived. A tradition that had existed for thousands of years did not become merely a paragraph in a history book. It became a living practice. A real canoe, a real ocean, a real voyage, and real human beings still finding their way across the world. That may be the deepest lesson of this entire story. The ocean was never the only thing these navigators had to overcome. They also had to overcome forgetting. Because knowledge can disappear just as easily as an island can disappear beneath the horizon. And sometimes, saving an entire scientific tradition depends on one person teaching another. One generation choosing to listen. One master deciding that the knowledge must continue. So the next time your phone tells you exactly where you are on the surface of the earth, take a moment to remember what that question once meant. Where am I? Which way is home? For thousands of years, the answer did not come from a machine listening to signals from orbit. It came from a human being standing on a moving deck in the darkness, watching a particular star rise exactly where they expected it to, feeling a familiar swell beneath their feet, watching the wind, reading the clouds, listening to the ocean, and trusting that the sky and the sea were telling them the way home. And incredibly, they were right.